Sustainable Cookstove Solutions is a multidisciplinary, entrepreneurial senior design team consisting of both environmental and mechanical engineers. This allows us to not only write and prototype on paper, but also get in the lab and create a physical prototype for our project by the end of the semester. The central problem that our project hopes to address is that many communities in sub-Saharan Africa lack accessible clean fuels and technologies for cooking. Instead, these communities rely heavily on coal and biomass, particularly wood, in addition to crop and livestock wastes as their cooking fuels, even though the emissions from these fuels are detrimental to their health and to the environment. Our objective is to create an adaptable, marketable, multi-fuel cookstove optimized for communities dependent on wood and coal. The cookstove will operate using a mixture of 50% liquefied petroleum gas, also known as LPG, and 50% di-methyl ether, also known as DME, an alternative, sustainable fuel. DME is a relatively simple compound made by either dehydrating methanol or through a synthesis of methane and biogas. When burned, DME produces almost no harmful particulate matter, which is why it was chosen as the alternative fuel. Our sponsor, EnviroFit International, is already doing work in the cookstove space, as its company objective is producing and manufacturing propane cookstoves for communities in sub-Saharan Africa and South America. EnviroFit provided us with a lot of guidance and advice throughout this endeavor, and also provided us with a cookstove from which we did all of our testing and design work. To source DME, we contacted Oberon Fuels, a company in California, who generously supplied us with various mixtures of DME free of charge. The mixtures were of 12.5% DME, 87.5% LPG, 50-50% DME LPG, and 100% pure DME. Using EnviroFit's cookstove, we conducted extensive testing on both LPG and DME. We first tested propane to get baseline data for the stove, from which we compared the efficacy of LPG to the various DME mixtures. We then tested the various DME mixtures to learn about each's efficiencies and heating values. Another point of note is that EnviroFit's cookstove was built for LPG, not DME, so we knew we would have to design a new nozzle to best suit the LPG-DME mix. Through these tests, we concluded that a 50-50 blend was the most optimal. With the fuel blend chosen, we moved into the nozzle design phase. We designed, prototyped, and constructed nozzles of various orifice lengths before testing each to find the most optimal option that balanced fuel consumption and rate of heat transfer. We ultimately chose a nozzle with orifice diameters of 0.049 and 0.021 inches for use in the final product. In the end, a high-powered, efficient, and economically viable cookstove was designed through technical experimentation and design modifications to the original LPG cookstove model provided by EnviroFit International. And despite some challenges along the way, the team is proud of the ability of the final cookstove design to operate at a high level of combustive performance. The initial commercial launch of the final cookstove product will be in the Imperial Valley of California and target recreational cookstove users. The DME supply chain will hopefully expand across the United States and eventually reach communities abroad. Therefore, the ultimate goal of the project remains providing individuals in sub-Saharan Africa and South America with sustainable and user-friendly cookstoves that reduce carbon and particulate matter emissions, and thereby protecting the environment and preventing illnesses and deaths related to household air pollution. Lastly, we would like to thank EnviroFit International, Dr. Thornton, Dr. Olson, and Don Grove for their guidance in this endeavor. This project couldn't have been possible without their help, and we are proud to contribute to a brighter and cleaner future.